Okay, this worksheet is on the mixed thermochemistry problems, would be worksheet number 2. I know there's 10 of them. I'm going to try to squeeze them all on here. We'll see how it goes. So calculate the quantity of heat. In this case here, we got a temperature change, so Q equals mc delta T. The mass is 300 grams. We're dealing with water, so it's 4.184 joules gram degree Celsius. And the temperature change is 69.2 degrees. And I decided to, since it says kilojoules, we know 1,000 joules is 1 kilojoule, and that equals 86.9 kilojoules. For number 2, same formula, Q equals mc delta T. In this case, we're asked to find what is the C value. So solving for C equals Q over m delta T. I just swung the m and delta T over. The Q value is given to us as 2 kilojoules. The mass is given to us as 23 grams. I know that 1 kilojoule is 1,000 joules, and the temperature change is 36.7 degrees Celsius. So my C value ends up becoming 2.4 joules per gram degree Celsius, just like the units we have here. For number 3, how much heat is required to raise aluminum? I'm going to write the values in. I did send you a separate email that's had these values in there. Again, I apologize. I didn't look at this ahead of time and realize there were certain values that were not included. I'll try to make sure that's a little better in the future. Okay, Q equals mc delta T. The mass is 498 grams of aluminum. The C value for aluminum is 0.897 joules per gram degree Celsius, and delta T is 15 degrees, equals 6,700 joules. For problem 4, what mass of iron would be required to provide 700 joules? Using the same formula, except now I'm solving for mass. So mass equals Q over C delta T. Heat value is given to us as 700 joules. Delta T is 20 degrees Celsius. And the C value again on that sheet, 0.449 joules gram degrees Celsius. Joules cancels, degrees Celsius cancel, left with grams, which is 78 grams. And number 5, again, says what is the heat of vaporization of this substance? Q equals M H of V. So heat of vaporization equals Q over M. The heat is 9,800 joules. And the mass, we're told, is 65 grams. And that equals 150 joules per gram. Like last time, I've got to switch to the other side. Problem 6. Sorry for stretching, getting my mug in it. You're asked to find heat of fusion. Q equals M H of F. So H of F equals Q over M equals 65.6 kilojoules over 238.5 grams. 1 kilojoule is, of course, 1,000 joules, And the answer is 275 joules per gram. Number 7, you're asked to find C. So Q equals MC delta T. C equals Q over M delta T. Q is 7,840 joules. The mass is 540 grams, and the temperature change is 18 degrees Celsius, and we get 0.81 joule per gram degree Celsius. Okay, on the back page then we had number 8, and it's masking for heat, so Q equals mH of V. And since we're dealing with water, 175 grams. Heat of vaporization is 2260 joules per gram. Equals, we have 4 significant digits in this one, so 3.955 times 10 to the 5th joules, or if you had 395.5 kilojoules. Number 9, you're dealing with magnesium. Again, that value is on that table. This time you're asked to find the delta T. So using our same formula, we end up with delta T, I'm using this formula here, equals Q over MC. And this is 600 joules, 390 grams. And the C value for magnesium, 1.026 joule gram degrees Celsius. Joules cancel, and grams cancel, left with degrees Celsius, and it's 1.5 degrees Celsius. And I apologize, another place in here we haven't canceled the units, but you can figure that I'm trying to keep the videos as short as I can. Okay, on number 10, Q equals heat of vaporization. So it's asked to find mass. Q over heat of vaporization. You're told that you have 9,460 kilojoules. 1 kilojoule is 1,000 joules. And I had to look this one up too. The heat of fusion, heat of vaporization for gold is 1,648 joules per gram. And you can see that joules cancels, kilojoules cancel, you're left with grams. And the answer is 5,740 grams of gold. So again, that's the second worksheet, and I hope this helps a lot. And please keep the questions coming. I'll do as best I can to answer them. Have a good evening. Bye.